So in this next problem, there's a roller coaster at the top of a hill. It weighs 300 kilograms. The hill is 40 meters tall and it's traveling forward at a speed of 2 meters per second. Part A asks, what is the speed of the roller coaster at the bottom of the hill, down here? So first of all, we need to understand something. At the top of the hill, the roller coaster has both potential energy and kinetic energy. For the equations, it's mgh plus 1/2 mv squared. And at the bottom, it will have just the kinetic energy, 1/2 mv squared. Now what we're solving for is this right here, this velocity at the bottom. So what we'll do is we'll set those equal. We're going to plug in our numbers. Plus 1/2 times the mass times the speed squared equals 1/2 times 300 times v squared, which we are solving for. So we'll do the little work here. We'll type it on our calculators. 300 times 9.8 times 40 equals 117,600, and then that's our potential energy component added to our kinetic energy. 1/2 times 300 times 2 squared, which is 600. That equals 1/2 mv squared, or 1/2 of 300 is 150 v squared. If you add those two together, you get this number, 118,200 equals 150 v squared. Divide by 150, and then take the square root of that, so we'll divide by 150. Square root of 788 equals 28 point decimal, but we're just going to call it 28. So that is our velocity at the bottom, which answers part A. The next step of the question asks, what is the speed at the top of this hill? And we're starting from down here. This is just the opposite of what we did. Before we said we went this way, and the potential plus the kinetic equals kinetic, but now we're going to have KE equals PE plus KE, because at the top of the hill it will indeed have kinetic energy. So we know the velocity at the bottom, so 1/2, its weight didn't change, times 28 squared equals mgh, 300 times 9.8 times the height now is 8, plus 1/2 mv squared. That's a v squared, 300 v squared, which we're solving for. So we'll type out the left side of the equation, 0.5 times 300 times 28 squared, and get a number. And we're going to type out this side, (23520) plus 150 v squared. Now we'll subtract this. (94,080) equals 150 v squared. Divide by 150, and then take the square root of it. Velocity at the top of the next hill is 25 meters per second.